Okay, so we want to do some operations with these scientific units and notation. So I'm going to do an operation here. Let's see. I looked up the radius of the Earth, and just out of curiosity, I want to find out what is the volume of the Earth in cubic meters. So I'm shooting for cubic meters, right? So meters cubed. And we already know the volume of a sphere. We did that back when we did the volume of different shapes, and that was 4/3 times pi times r cubed. So r in this case is going to be 6. So let me first convert this to meters. So 6,378 kilometers. Well, each kilometer is 1,000 meters. So I'm going to change this into 6,378 times 10 to the third meters. And if I wanted to make it into scientific notation, I would need to move that decimal place over 3 more spots to make it 6.378. And that would be 10 to the, and I moved it over 3 spots, so this is a bigger number now, 10 to the 6th meters. Okay, so in scientific notation, that would be equivalent of 6,378 kilometers. Would be 6.378 times 10 to the 6th meters. All right, so 6.378 times 10 to the 6th. And this is the radius cubed. All right, so if I have a power to a power, we should have 4 pi or 4/3 pi times. Now I'm going to take each part inside this parentheses is going to go to the third power, so 6.378 cubed times 10 to the 6th cubed. All right, and a power to a power, we just multiply exponents, right? This is the same as 10 to the 6th times 10 to the 6th times 10 to the 6th. So 6 times 3, which would be 18. Okay, so I'll probably have to get out my calculator here, but this is 4/3 pi. That I'll figure out on my calculator times 10 to the 18th. This is going to be, each of these is in meters, so this will be meters cubed as well. So I also cube the unit. All right, so let's grab the calculator and have 6.378 cubed is 259. I'm going to go ahead and multiply it times pi, 3.14.5, and then multiply that also by 4/3, so 4 divided by 3. So I get 1,000, so this was 6.3 cubed. So a total of 1,087 times 10 to the 18th meters cubed. And I want to make this in scientific notation, so I need to move it over 3 more spots to get 1.087. And since I move over 3 spots, I add 3 more to that. So 3 plus 18 would be 21 meters cubed. All right, so that is the volume of the Earth in meters cubed. Now, how about a basketball court? I want to find the area of a basketball court. Maybe in square centimeters. So this is the unit I want to shoot for here. So first, I convert this to centimeters. So each meter is 100 centimeters. So I'd multiply times 100, so 28.65. And actually, let me just show you a little trick that I used for conversion. So I make this little chart. Let me get rid of this. And I say, okay, I want to say there's 1 meter, there is 100 centimeters, right? And you can just put your units that are the same. This is just like dividing by itself, right? So this is just like a 1. So all I'm doing is changing, I'm getting rid of meters. I divide meters by meters and get rid of it, and I turn it into centimeters. So this is a little trick that I use for conversions. So now I just do 28 times 100, which I can do that in my head. It's 2,865. And then you do the same thing to the other unit. And this is in centimeters now. And multiply that by 100, you would also get 1524 centimeters. So the area would be that times that. And I'm going to convert it to SI, or to scientific notation, so I move it over 3 spaces, times 10 to the third centimeters, and I'm multiplying times 1.524 times 10 to the third centimeters. So when I multiply these together, I can rearrange them and group the 10 to the third times the 10 to the third, which would be 10 to the 6th. I just add exponents. And then I have the 2.865 times 1.524 together. And I'll multiply those on my calculator. 2.865 times 1.524. Oops, I did plus. Times. So 4.36, so I'll just round that to 4.36 times 10 to the 6th centimeters squared, because I did centimeters times centimeters, so this is square centimeters. Okay, and if this came out in scientific notation, but if, for example, it came out instead of 4 point, it was like, I don't know, 34.5 or something, times 10 to the 6th. I want to make it into scientific notation, so the way I would do that is I'd move the decimal place over 1. So 3.45. And then to make it correct, I have to multiply it by 10, right? So that'd be 10 higher. So this would be 10 to the 7th. So sometimes you have to do that when you multiply it out and it doesn't come out in scientific notation. This one did. But if it doesn't, you have to correct for that. And so 35 times 10 to the 6th is the same as 3.5 times 10 to the 7th. Okay, last problem. How about we do that? Let's find the weight of the sun. It's given as the density of the sun is 1.4 grams per cubic centimeter, and then the radius of the sun is that. So how would I find the mass of the sun? So density is mass per unit volume. So if I can get the whole volume of the sun, right, and then I have in cubic centimeters, and then I take the number of cubic centimeters that the sun is made up of, and I multiply it times 1.4 grams per cubic centimeter, that would give me the total mass. Okay, so first I need to find the volume. So the volume of the sun. So this is a multi-step problem here. The volume of the sun will be, again, we're using 4/3 pi r cubed. So I need to, let's take this and turn it into scientific notation. So 6.955 times 10 to the, let's see, 3, 4, 5, 10 to the 5th kilometers. And actually I want to go to centimeters, so let's see. So to go from kilometers to meters, it would be 10 to the 3rd, so I'm going to add 3 to that. So kilometers is 10 to the 3rd, so I'd be at 6.955 times 10 to the 8th meters would be the radius of the sun. And then I want to go to centimeters, so centimeters is another 10 to the, there's 100 centimeters in a meter, so I'm going to multiply by 10 to the 10 squared. Okay, so 2 more, so 10 to the 10th centimeters, right? All right, so now I use that. 955 times 10 to the 10th cubed, and so 4/3 pi times 6.955 cubed. This is centimeters times 10 to the 10th cubed times centimeters cubed. cubed. So I have 1,409, and then that's times 10 to, so power to a power, I multiply exponents, so 3 times 10 would be 30 centimeters cubed. Now this is not in scientific notation, so I need to move it over 3. So 1.409 times 10 to the 33rd. Right, so I added 3 more centimeters cubed. Now, that's the volume, but I want to get the mass, so the mass of the sun would be, every single centimeter cubed weighs 1.4 grams, so I just multiply 1.4 grams, and actually I could do this per 1 cubic centimeter, right? I could do it in that style of conversion. Is 1.409 times 10 to the 33rd centimeters cubed. Alright, so centimeters cubes cancel, and I'm going to be left with grams. So all I have to do is multiply 1.4 times 1.409. And it comes out in scientific notation. So 1.9726 times 10 to the 33rd grams. So if I wanted to get that into kilograms, all I would do is say, well, every 1,000 grams is a kilogram. So all I would do is drop 3 exponents, so it would be 10 to the 30th kilograms. Okay, so that's like 2 with, rounding that to 2. That's 2 with 30 zeros behind it. So imagine how big of a number that is. Yeah, 30 zeros is quite a big number. So it's a pretty large star, although I think there are stars that are much bigger.